you look at the only building that's up in space right now, which is the ISS, that cost $150 billion to construct. And it required something like 40 launches to send the modules up. So it's very expensive, dangerous work to build in space. So the solution for building on Mars, we believe, is to do it autonomously with robotics and to use the Martian material as a 3D print material. So effectively, you're not sending over anything other than a fleet of small robots, and then you can construct a scalable infrastructure. I'm a skyscraper architect. That's my background. So I've been working in doing skyscrapers for 20 years. Before architecture, I wanted to be an astrophysicist. So now that the work that we're doing in space kind of puts those two passions together. When NASA had this competition, we sort of leapt at the opportunity. From the NASA competition, it started with the design phase, but then the final challenge was a construction of a prototype. So we 3D printed a 15-foot tall structure in 30 hours, made from this sort of Mars-relevant material, which is a composite of basalt and PLA. So basalt is the rock that you commonly find on Mars. PLA is a biopolymer, but essentially like the bulk of the material is the Martian regolith. So it was a challenge for NASA. It was completely autonomous. So the actual operation was about 95% autonomous and 5% sort of remote intervention via the operator. Now we're sort of taking what we learned from that experience and building Terra, which is our Earth application. And so, if you think about what it means to build with sort of local resources in an Earth context, is very sustainable because you're sort of decoupling yourself from like steel and concrete, which are these high energy manufactured materials, and then building on site, right? So you don't have the transportation and the logistics that you normally would with construction. So we think it's a much more sustainable way for building on Earth. So it's quite interesting how the space technology then plays out to kind of like take us the next leap forward and how we build things on Earth. So the prototype that we built for NASA, which we call Martia, was actually ground up after the NASA competition, and we're using recycled material to print Terra. So Terra, when it's completed, will be a 500 square foot, 2-story tiny home in the woods, made completely from recycled material. And now we know that the material itself is recyclable. So, at the end of the building's life cycle, we could technically knock it down, grind it up, and reprint it again. So it's sort of interesting how this space tech came to play out as a sort of, circular construction technology here on Earth. So we think that's where the best benefit is. So Terra is the sort of earthly cousin of Martia. It's shaped like an egg, okay? And that really goes back to Mars. And, the fundamental forces that you have to deal with Mars is the difference with the internal air pressure inside the habitat versus the external air pressure. So the Mars atmosphere is very thin, and so the air on the inside wants to push on the outside. So the egg-like shape is the most efficient structural form for dealing with those structural forces. So on Earth, you don't have the same issue because the inside air pressure is about the same as the outside. But we do have things like wind and snow, and actually we find that this egg shape is actually good for addressing those two issues as well. The dual use technology, I think the designing and building for the extreme environments of space, I think then give us this quantum leap forward in construction technology which we can apply on Earth. So there's a common criticism about why are you building in space? There's so many problems on Earth, like homeless and disaster shelters and stuff. And I think the whole point is that by considering and designing for the extreme, I think yield solutions which ultimately will be very scalable and potentially cost effective as well for addressing these sorts of situations. But you sort of have to almost shoot for the stars, I think, to come up with that sort of solution. Before Mars, there's the moon. For Mars, I think the timeline is looking something more like between 2030 and 2040.